Hello everybody, welcome to Mathethics original channel. Thank you for watching our video, and please don't forget to like, share and subscribe. In today's lesson, I want to talk about the difference between the recursive formula and the explicit formula. And to do this, we're going to use those four tables as example. So some of those tables are arithmetic sequence, and some of those tables are geometric sequence. But for either one of them, whether it's arithmetic or geometry, the recursive formula have the same purpose and the explicit formula have the same purpose. So remember, every time you are giving a sequence, the first thing you need to ask yourself, or you need to find out, is to determine whether you are dealing with a arithmetic sequence or a geometric sequence. For instance, the first one, we have this sequence right here. Okay, so the first term, so that those are the terms, and those are term numbers, and those are the value of each term. So the first term is 4, the second term is 7, the third term is 10, the fourth term is 13. So is this an arithmetic sequence or a geometric sequence? The way to find out is looking at the difference between any two consecutive terms. So let's take the first and the second term. So the difference between the first term and the second term, which is 4 and 7, is 3. Because 7 minus 4 is 3. So in order to get the first and second term, we add 3. And the second term and the third term, we also add 3. So therefore, I know I'm dealing with an arithmetic sequence because the pattern of adding 3 continue for each consecutive term. So now, let's go ahead. So I know this is an arithmetic sequence. Now let's go ahead and write out the recursive formula of that sequence. Now, the difference between the recursive and the explicit formula, the recursive formula allows you to find the next term of that sequence. It doesn't matter if it's arithmetic or geometry. The goal of the recursive formula is to find the next term of that sequence. But the explicit formula allows you to find any term of that sequence. Okay, the value of any given term of that sequence. So for the explicit formula, you do not have to know the previous term. When for the recursive formula, you have to know the previous term. So if I want to find the fifth term of that sequence, because I know the previous term of the fifth term, which is the fourth term, and I know that's 13, then I can use the recursive formula. So remember, the recursive formula for an arithmetic sequence is a sub n equal a sub n minus 1 plus the common difference. Or you can say f of n, that's another way the function notation, f of n equal f of n minus 1 plus the common difference. So either way it's mean the same thing. Okay, so a sub n minus 1 and f of n minus 1, these are just the previous term. Alright, so these are the term we're looking for, these are the previous term. So therefore, for this table, I can say, well, f of 5 or a sub 5 equal a sub 5 minus 1 plus the common difference here is plus 3. So 5 minus 1 is 4. So a sub 5 equal a sub 4 plus 3. And don't we know a sub 4? Yes, we do. So a sub 5, the fifth term, is equal 13 plus 3, which is equal to 16. So therefore, this sequence right here, this term right here is 16. And looking at the pattern, that makes sense. 13 plus 3 is 16. Okay, so if I were to write out the recursive formula for that sequence, it will be a sub 5. So a sub n would be a sub n minus 1 plus 3. Okay, so that's how we use, or we find, using the recursive formula, we can find the next term. But if I ask you to find the 100th term of that sequence, if I ask to find the 100th term or the 50th term or even the 20th term of that sequence, you would eventually find it using the recursive formula, but it will take you a long way. So because of that, to find the 100th term, okay, so we're going to find the 100th term of that same sequence. Find the 100th term of that same sequence. Okay, talking about this sequence right here. So we're going to find the 100th term. So because of that, we have to use the explicit formula. And the explicit formula saying that so the explicit formula is a sub n equal the first term plus the common difference factor of n minus 1. Okay, a sub n equal a sub 1 plus the common difference factor of n minus 1. And that's also the same thing in the function notation. We can say f of n equal a sub 1 plus the common difference factor of n minus 1. It's the same thing. Okay, that's the function notation. So if I want the 100th term, so I'm gonna erase this for now. If I want the 100th term of that sequence, so I can say, well, a sub 100 equal the first term, which is 4, the first term is 4, plus the common difference, which is 3, factor of 100 minus 1. So which is 4 plus 3 times 100 minus 1 is 99. So we have 3 times 99. So equal 4 plus 297, which is 3 times 99, and that's equal, so we can say a sub 100 equal 4 plus 297 equal 301. So the 100th term of that sequence will be 301. Okay, so that's the difference. But if I were to use the recursive formula to find the 100th term of that sequence, it will probably take me forever. Okay, so let's try another one. Let's see this sequence over here. We got the first term is 1, the first term is 3, the second term is 6, the third term is 12, the fourth term is 24. Again, what are we dealing with here? So if I find a difference between 6 and 3, that's 3. So that's when 3 plus 3 is 6, but 6 plus 3 is not 12. So therefore, it's not an arithmetic sequence. Another way I can do that, if I do 6 divided by 3, I get 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So therefore, I'm dealing with a geometric sequence. You multiply the first term by 2 to get the second term. And you multiply the second term by 2 to get the third term. And the pattern continues. So with that being said, we know we are dealing with a geometric sequence. So that's a geometric sequence. So with the geometric sequence, we can go ahead and find the recursive formula. So remember, the recursive formula is simply a sub n equal a sub n minus 1 times the common ratio. And that time 2, the 2 is your common ratio because you multiply by 2 each term to get the next term. So if you want a function notation, we can say f of n equal f of n minus 1 times r. So that's the function notation. So all that means, this a sub the n minus 1 means the previous term, and then the r is your common ratio. So if I want this fifth term, I can use the recursive formula to find it. So the fifth term will be f, or let's say a sub 5 for the fifth term, a sub 5 equal the previous term. Okay, the previous term of 5 is term 4, so which is 24 times the common ratio is 2, so times 2, and we can say 24 times 2 is 48. So here we got the fifth term equal 48. 24 times 2. Now, for the nth term, I cannot, let's say if n is equal to 20, okay, if n is equal to 20, so that means I have to do this step another 15 times before I get to 20. So there's the easiest way. So n can be 20, n can be 100, n can be 1,000. So if you're using the recursive formula for this to find 1,000 term, it will take you probably a long time, a whole day, or even like a long time, days. So let's see, for this case, we can use the explicit formula. Remember, the recursive formula allows you to find the next term, but the explicit formula allows you to find any term of that sequence. So I'm going to erase this. And we're going to write out the explicit formula for this one. So now remember, the explicit formula for a geometric sequence is a sub 1, so a sub n equal a sub 1 times the common ratio raised to the power of n minus 1. Common ratio raised to the power of n minus 1. Okay, so what does that mean? And again, in function notation, you can always put f of n equal the first term times r n minus 1. Same thing. So now to find the nth term, let's say n is equal 20. Let's say n is equal 20. Okay, so to find the 20th term, I'll say, well, a sub 20 equal the first term, which is 3, times the common ratio, which is 2, raised to the power of 20 minus 1. So which means 3 times 2, 20 minus 1 is 19. Okay, to 19 power. So let me go ahead and do that real quick. Three times 2, 3 times 2 to the 19 power. So that's giving me about 1,000,000. So it's a big number. So that's giving me the 20th term is equal to 1,572,864. Okay, so that will be my 20th term of that sequence. If the pattern continue, that's what I will get for the 20th term. Okay, so again, it's better to use the explicit formula when you need some term that you don't know, when you do not know the previous term of the term you're looking for. Okay, so let's look at another example. So I'm gonna use this. So let's look over here. What type of sequence we're dealing with? Over here, 4 and 1. So to get from 4 to 1, so if you do 1 minus 4, that's equal -3. So 4 minus 3 is 1. 1 minus 3 is -2. And -2 minus 3 is -5. So this is an arithmetic. So is minus 3 is -5. So this is an arithmetic sequence. This is an arithmetic sequence. So now to write out the recursive formula to find the 5th term, we can use the recursive formula. So the recursive formula will be -4 a sub 5 a sub n equal a sub n minus 1 plus the common difference. And in this case, we already know what the common difference is, and we already know what the previous term is. So a sub 5 equal the previous term, which is the 4th term, and the 4th term is -5 plus the common difference, which is -3. So plus minus give you minus. So if the common difference is negative, we just put negative here. -5 minus 3 is equal to -8. So a sub 5 equal -8. So that's the 5th term. Okay, but for the nth term, let's say n is equal to 50. If n is equal to 50, so in order to find the 50th term, we have to know the 49th term, and we don't know the 49th term. We don't even know the 48th term. So in that case, you have to use the explicit formula, or the best way to go is using the explicit formula. So let's see what the explicit formula say. For an arithmetic sequence, so the explicit formula is a sub n equal the first term plus the common difference n minus 1. So a sub 50 equal the first term that we know is 4 plus the common difference we know is negative 3. So therefore, we're going to have a negative instead of plus 3 factor of 50 minus 1, which is equal to 4 minus 3 times 49. 50 minus 1 is 49. So 3 times 49 is 147. So equal 4 minus 147. So, and 4 minus 147 is equal to negative 143. So, in this case, the 50th term will be negative 143. But to do that, I had to use the explicit formula. Okay, so again, recursive formula help you to find the next term, but explicit formula help you to find any term. So let's do our last example here, which is this one. So what type of sequence we are dealing with? So over here, if you look from this 256 and 128, so we can see 128 is half of 256. So you divide by 2 here to get 128. So when you divide by 2, it's like multiplying by 1/2. Okay, and 1/2 is the same as 0.5. So 128 divided by 2 is 64. Okay, you multiply by 1/2, and here you multiply by 1/2. So which means you divide by 2. So that's how I know I have a geometric sequence. So that geometric sequence. So when you have the geometric sequence, we can use, to find the fifth term, we can use the recursive formula because we know what the fourth term is. If we know the fourth term, we can find the fifth term by using the recursive formula. So the recursive formula say a sub n equal a sub n minus 1 times r times the common ratio. Okay, so in this case, a sub 5 equal, the previous term is the fourth term, so which is 32 times the common ratio is 1/2, okay, which is divided by 2. So in 32 divided by 2 is 16. So FF equal 16. So this one right here will be 16. Okay, but what if we need to find out the nth term? So if n is equal to 10, okay, so we're gonna find out the nth term when n is equal to 10. So in this one, we're gonna use the explicit formula, because for me to use the recursive formula, I have to have the ninth term, which I don't have the ninth term, and then I'll have to find the 8th term. So in order to find the 10th term using the recursive formula, I'll have to find the 6th term, the 7th term, then the 8th term, then the 9th term before I find the 10th term. But with the explicit formula, I do not have to do all that. I'm going to erase this. So I do not have to do all that for the explicit formula. So I can simply use the explicit formula, and that's enough for me to find the 10th term. So we're going to use the explicit formula in this one. So the explicit formula say that a sub n a sub n equal the first term time the common ratio raised to the power of n minus 1. So, which means a sub 100, the 10th term, equal the first term, which is 256, time the common ratio, which is 1/2, raised to the power of 10 minus 1. Okay, so 10 minus 1 is 9. So we can say A10 equal 256 times 1/2 raised to the power of 9. Okay, so let's see what that gives us. And that's equal to 1/2, 1/2. So that's the 10th term, or 0.5. So remember, the recursive formula helps you to find the next term of that sequence knowing the previous term. The explicit formula helps you to find any term of that sequence even though you do not know the previous term. So that's the difference between recursive formula and explicit formula of an arithmetic sequence or a geometric sequence. Thank you so much for watching. Please don't forget to like, share, and subscribe, and I'll see you next time for the next video.